Good afternoon. I am Francesca Noardo from the 3D GeoInformation group at the TU Delft. Here I will present the main results of a project aiming at implementing a digital building permit process in the municipality of Rotterdam. I will give an overview of the digitalization tendency recently spread, within which the Rotterdam project was born. After that, I will present the work we developed in order to implement a digital tool supporting the municipality in building permit checks. We started from a case study, analyzed regulations and the available data, of course, formalized the regulations, and finally implemented a demonstrator. The background of this work is the digitalization process, which is ongoing all over the world, with the aims of improving efficiency, improving the quality of services and cities, reusing the data effectively, enabling advanced analysis, and of course, saving time and money. In particular, for building permit, several initiatives and pilots are developed in the world. Some of the closer ones are the EuroSDR GeoBIM project involving several European countries, the European Network for Digital Building Permit, born specifically for this aim, and the European Directive on Public Procurement, ruling the adoption of digital technology for building permit. In the city of Rotterdam, a digital city pilot is running as well, within which this project was funded. The aim of the project was the development of a methodology and a tool able to support the municipality in the check of some regulations, namely building dimensions, which is the object of this presentation, and the provision of parking places. The biggest challenge of the project was the use of data as produced by practice and the actual municipality regulations, for which a close collaboration with the municipality officers was planned. The use methodology adopted, therefore, a bottom up approach. After the selection of a case study, including regulation, area, and data, we analyzed all the involved components, formalized the regulation, and implemented a tool consequently. The case study was in the Maritime District in the center of Rotterdam. The dimension regulation was considered for two buildings planned in the area. The IFC models produced by the architects of these two buildings were available for the project. When reading the regulation in order to formalize it, many ambiguities and uncertainties can be detected, and several doubts had to be solved by the municipality experts in order to just understand how to interpret it correctly, even without the additional challenge of making them machine readable. To help in this process, two workshops were organized by the municipality in order to have the opportunity of easily interacting with the involved experts and having all our questions solved and answered. Besides analyzing the regulation, we inspected the provided IFC models and we could notice some issues that could prevent some automatic processing. It is important to consider them when designing the tool and maybe trying to fix these at least in future through the guidelines to modelers that we will provide. After that, the regulation was translated to a formal language, enabling the conversion to machine-readable rules in the next steps. And the last steps consider the implementation of the tool and the use of it with the available data for checking the regulations and make the useful measurements that are necessary to make the checks. A fundamental premise is the good quality and the georeferencing of the IFC models, for which we provided some guidelines. And then, essential to check the dimension regulations is the extraction of a suitable and useful building envelope, segmented consistently with what would be decided by a human mind interpreting the building drawings. according to the traditional workflow, which is now ongoing in the municipalities. It is therefore necessary to detect the facade discontinuities and decide which ones represent an actual discontinuity and which ones are just a neglectable facade articulation. This decision is not straightforward as it appears in the picture on the right. A minimum dimension or difference percentage should be chosen to identify the building discontinuities. This slide summarizes how the tool that we developed solved this issue by cutting the building in slides at a useful height first, and later the footprint of each floor was used to calculate the reciprocal overlappings, and the threshold to overlapping percentage was chosen to identify where the building could be properly segmented. Finally, the calculation of the overhang distances towards the two adjacent streets was also calculated through a more articulated workflow. In the bottom right corner, we can also see the conversion of the polygons extracted from the BIM to GIS format, which can be used, for example, to update the maps. In the next steps, specifically for this check, a stricter connection to the city model will be useful and will be implemented to automatically detect which is the side towards which streets of the building. To conclude, the adopted bottom-up approach was essential to explicate the several sub-issues which are involved in such a complex processing. This implied a slower start, but the definition of the problems and the articulation of them in the necessary processes brings a great advantage to the development of further steps and improvements to the initial demonstrator that was now implemented. The GeoBIM integration was for the moment only partial, since many challenges arose in the initial phases regarding only the IFC file, but it will be critical in the next developments. The possible future work is huge, but these are two likely next steps. So the test of alternative algorithms to detect the exterior facade geometry and the extension of this tool to the whole city and not just to one only area. You can find more information in the website of the project or in the GitHub repository where the open source tool is stored. And thank you for your attention.